So start the class at around 6:05. I'll wait 5 minutes if more students join and all, then I will start discussing the sample.
What? ಆಟಾಗ ಇವನ್ ಕೊಟ್ಟಲ್ಲ ಇವನು ಜಾಯ್ನ್ ಆಗಿ ನೋಡಿ ಇವ್ ನೋಡ್ರಿಲ್ಲ ಸಂಜೆ ಯಾರು ಮೆಕ್ಯಾನಿಕಲ್ ಫೋರ್ಸ್ is reinforcement composite.
Sorry guys for the inconvenience. Actually, the Wi-Fi stopped working in my hostel, so I had to come outside. I hope I am audible. Am I audible? Is the screen visible to everyone?
Yes, ma'am.
Okay.
Yes, 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 ma'am.
Okay.
Yes, ma'am.
So welcome to the course Mechanics
Yes, ma'am.
Reinforced Polymer Composite Structure. So this is the live interactive session number 1. Today I am going to solve some sample problems which are based on the assignment number 1. And my name is Ananya Mandal. I am one of the TAs of this course. Okay, so let's start.
Okay. Okay.
So the first question is that in composite materials, the matrix phase is space while the reinforced phase is space. So the options are A, continuous, discontinuous, option B, discontinuous, continuous, option C, heterogeneous, discontinuous, or option D, stiffer, weaker. So as you guys have already must have seen sir's lectures, so you guys know what is composite material. So composite material is something which has two or more phases in it, and mostly these phases are defined as either matrix phase or reinforcement phase. So the matrix phase acts as the base of the composite, and the reinforcement phases are mixed with the matrix phase. So as you can see in this diagram here, this is a reinforcement phase, which are like fibers. As already discussed in the class, there are different types of reinforcement. They can be fiber, mat, particles, flakes, and everything. So here I am considering a reinforcement fiber. So these fibers act as reinforcement, and when they are mixed with another phase, which is a matrix phase here, which is a polymer matrix phase, this becomes a composite. So that is defining what is a composite. Now they are talking about this matrix and reinforcements, how they are. So you can see in the composite, the reinforcements are one which you can differentiate in the composite, whereas matrix is uniform. So as these reinforcements can be separately seen in our composite, and they are not connected to each other. As this reinforcement is separate, this reinforcement fiber is separate. So they are separate to each other, that means they are not continuous. So they will be discontinuous. This option is for the reinforcement. Whereas the matrix phase is all around the reinforcement. So it is the one which is combining all these reinforcement fibers together. So it acts as a like a glue to all the reinforcement fibers, and it is continuous as defined in the class. So as defined in the class, continuous phase are those which any point you will find it. So you can, as you can see the cross section here, you can see all these reinforcements are separate, but it is the matrix phase is all continuous. So the option for this question will be that the matrix phase is continuous and the reinforcement phase is discontinuous. That is option A. Next question is, composite materials have dash constituents. So option A, only two different constituents, option B, only a single, option C, two or more different, or option D, only three different. So as the definition of composite says that it constitutes two or more phases and two or more components in a makes a composite. Anything above two makes a composite. As you can see here, there are some examples. The first one is a carbon fiber and epoxy pipe. This one. So here, can anyone tell which carbon fiber and epoxy, from that can anyone tell which is reinforcement and which is matrix?
Carbon
Epoxy is the
fiber is the
matrix.
reinforcement.
Fiber is,
Epoxy is the matrix.
fiber
Yes,
is
ma'am.
the
Epoxy is matrix. Carbon
fiber is the
fiber is
reinforcement.
reinforcement.
Yeah, okay, right. So this composite is made of two phases, the reinforcement matrix, and here the reinforcement is carbon fiber and epoxy is acting as a matrix. So only there are two components. Whereas the another example, you can see concrete is a mixture of adhesive aggregate giving a rubber strong material that is very widely used. So this is a concrete. This concrete is also a composite. But here you can see the matrix phase is like the cement, and all these small particles, these are like different stones and everything. These are the different reinforcements. So here there is not only two constituents, that is there is the cement as well as the stones and gravels and everything. So these all makes the whole composite. So it can be more than two. Another example is the hybrid composite. Hybrid composite, like in this case there was carbon fiber and epoxy, only two components. Here they have the matrix, they can be having the matrix as epoxy or polyester and anything polymer, and the reinforcement is here you can see is this white part and black part. So mostly this black part is your carbon fiber and the white part is glass fiber. So here there are two different types of reinforcements and a single matrix. So that shows that there are more than two, that is three here, three constituents. So the option here correct will be option C, that it has two or more different constituents that makes a composite material. Now the next question is, the constituents in a composite combine on a dash. Option A, microscopic level, option B, macroscopic level, option C, atomic level, or option D, nanoscale level. So whenever we talk about composites or any material which has two or more components in it, another name that always comes in our mind is alloys. As we have already studied that alloys are those which contains different types of metals combined to each other. But alloys are different from composites. Why? Because composites are here all the constituents can be defined in a macroscopic level. As you can see in this diagram, you can see the different constituents in this composite. These are the fibers, and overall there is a matrix. You can differentiate the fibers from the composite. Whereas in alloy, they are combined at a microscopic level. Here the different, when you see an alloy metal, you can't see like, okay, this part is this metal, this part is that metal. No, they are combined at a microscopic level. So that is one difference you can that will be helpful to understand what is the difference between composite and alloy. Alloy is mixed at a microscopic level and composite at a macroscopic level, such that you can differentiate different components of a composite. So the answer of this question will be option B, that it is at a combined at a macroscopic level.
Ma'am, I see in some books the composite material is also for the microscopic in some cases like that.
But mostly when the main focus of comparing a composite, like there are different composites. There are composites which are done by nano composites. They have particles at nano phase. Maybe those you can say that because nano is always smaller size than microscopic. But in general, composites we define as the constituents are in a macro phase. There are some exceptions, as this composite definition came very early. Now there are new things happening, like in the course of Sir also. He talked about nano composites. It has nanoparticles and all. So if you see through the size, then obviously the size is lesser than micro. So you can say that about that. But earlier definition and the proper definition of composite is like that we can differentiate all the components through our naked eyes, and it is macroscopic. One minute, okay. My battery is down.
Hello, ma'am.
Yes, Vinoda.
Hello.
Hello.
Hello, ma'am. I'm Vinodha here.
Hi. Yes.
That microscopic is the part of the. Hello.
Hi. Yes.
Yes, ma'am. I'm Vinodha, ma'am here.
Actually, I'm not. Your voice is cutting. Can you type in the question, like in the chat box?
Hello.
Ha, Vinoda. Can you type in the chat box your question here in the messages? And yeah, Anuj, you wrote the definition. That is correct. That they are combined on a macroscopic scale.
Hello.
Hello, am I audible?
I'm audible, ma'am.
Hi, you're audible. Am I audible? Because my network
Hello.
is very bad.
Hello, ma'am.
Hi, hello, am I audible?
Yes, yes, ma'am.
Okay, I'm so sorry. The Wi-Fi is like not working properly in my hostel, so I have to like go outside and come inside and use my mobile data. But I hope now Wi-Fi came.
Okay.
So sorry.
Ah, okay,
Yes,
ma'am.
yes,
As
Vinoda.
you told, yeah, as you told, na, ma'am, that one microscopic is the part of the testing, na, ma'am, NDT.
Additive? Additives can also be
Eh,
added in macroscopic also. Like additives are different. You can't
ah,
talk about additives as a composite mostly. Additives are most like you can add additives in the matrix to improve the conditions of the matrix. So that is a different thing. Only additives, when you're talking about composite, you can't take additives as a reinforcement to it. Okay, additives and
okay.
fillers, these are two improve because they improve one of the phases, such as they like nanoclays are used in like polyethylene or something. They improve the polyethylene properties, but when we are considering one phase, we take the properties of that whole phase. So we will be saying that this is an advanced polyethylene because it has some additives in it, whereas we are still considering it as one matrix, that is the polyethylene is the only matrix. Okay, so fillers and additives and all, they don't come
Okay.
as a constituent of a composite. They are just there because when we are like later you will see how lamina is formed, how laminate is formed. So there we are studying the properties of each, like the reinforcement and matrix separately, and then we are combining and then studying how their combination is making the composite. So at that time, those uh, different constituents whose properties we are considering, only we consider those, not these fillers and additives which only enhance one of the properties. So you can't say when you add those things that that is also composite. So that goes away from the definition of composite totally. Okay.
Okay. Okay. Thank you.
So this question's answer we got that constituents of composite combine on a macroscopic level. The next question is reinforcement generally acts as hyphen members, whereas the matrix acts as this. The options are A, binding, comma weaker. Option B, load bearing, comma binder. Option C, continuous, comma discontinuous. And option D, binder, comma load bearing. Now reinforcements, uh, the first thing that came was like polymer. So we got polymer initially. Now this polymer has very less, like its properties are not that good as compared to like other components that we use for our daily use, like metal, ceramic and everything. So we have this polymer. Composite came after. First polymer came. Now we thought, okay, how we can enhance this polymer. So in that polymer, you added some reinforcements. So mostly the matrix part is our polymer and the reinforcements are different fibers or something. Now when combining it with the polymer, we got a final composite which has the the additive strength of both the polymer matrix and the fiber reinforcements. That's why now from what I just explained, we can see reinforcement acts as the load bearing. Why? You can see in the screen. So first of all, what are reinforcement that are mostly
Hello.
used?
Hello.
Hello? Is the screen not okay?
Voice is not hearing, ma'am.
Oh, am I audible?
Now, okay, ma'am.
Okay, and is the screen visible?
Yes. Yes. Yes.
Okay. So reinforcements generally act as this hyphen members, whereas matrix acts as hyphen. So options are A, binding, comma weaker. Option B, load bearing, comma binder. Option C, continuous, comma discontinuous. And option D, binder, comma load bearing. Okay. So now the concept of composite came later. First came was polymer. So we had this polymer, and but when we comparing it with other materials like the metal and ceramic which we already use for heavy duty work, we think of that how we can enhance this polymer. So for enhancing that polymer came reinforcements. The reinforcement what we mostly use, as you can see here in the diagram, this is only talking about glass fibers. There are different types of fibers: glass fiber, carbon fiber, aramid fibers, and these all fibers, they are in different forms. Like here you can see this is a mat, glass fiber mat. There are normal like uh, fabrics also, normal fabric mat. There are chopped strand mats and everything. So there are different forms of reinforcements. Now these reinforcements came and then got combined with our polymer, and that made the whole composite and its property comparable to the other initial materials that we used to use, metals and ceramic and all. So as what I said, from that you can see that this when these reinforcements came in the picture, then only the strength increased. So also you can see here in this table, this is the table which shows the properties of fiber and the matrix. The fiber is the reinforcement. So for different fibers like carbon fiber, Kevlar and glass fiber, the modulus, tensile modulus you can see is so much higher, 131 gigapascal, 75.8 gigapascal and all. Whereas for matrix, it is 4.6 or 400. I think this will be 4, not 400, 3.5. So this is very less. And here the modulus is very high, which shows that whenever there is a composite, the part which is actually uh, acting like supporting the force is the reinforcements like these fibers. So these are the load bearing one. Whereas what the matrix does, it acts as the polymer. So it is like a continuous medium, and it binds all these reinforcements to each other. And also whenever there is a force acting on this composite, the glass fibers will hold the force, and from one glass fiber to another glass fiber, the dissipation of the force will be done by the matrix. So later when we will be studying more about the reinforcement and matrix, you will see the different how the force is getting dissipated throughout the composite because of them. But right now the matrix acts as a binder and the reinforcement as the load bearing. But later you will see how this matrix also not bears the load, but it dissipates the load also throughout the composite. The next question is, reinforcement's phase is dash and the matrix phase is dash. So the options are A, more stiff and strong, comma less stiff and weaker. B, less stiff and weaker, comma more stiff and strong. Option C, continuous, comma discontinuous, and option D, discontinuous, comma continuous. So about the discontinuous and continuous, I think we have already discussed here in the first question. So from that we already know that the reinforcement phases are discontinuous and the polymer matrix forces phase is continuous. So this will be one of the answer. And the second answer, less stiff and weaker or more strong and stiff and strong. So from this previous discussion we can see that the load bearing is our reinforcement. So load, as the reinforcement is bearing all the load, it has to be more strong. And also from this table you can see their modulus values are high of the reinforcement than matrix. So option A will be your correct answer, that the reinforcement is more stiff and strong, whereas the matrix is less stiff and is weaker. So
Ma'am, sometimes your voice is not coming.
I'm not properly audible.
Sometime it will not coming, sir. No.
And are others also having the problem?
Ma'am, sometime.
Okay, after I discuss all the questions, if you have like doubt, you can see the PPT properly, right? So if you have like certain doubts, you can after I do all the question, you can ask. Arey yaar, why it's gone again? This Wi-Fi is going on the phone. Okay, after I discuss all the questions, if you have any doubts, then again I will discuss those questions. Okay. So I think the network is having a lot of problems. So sorry for that. Next time I will like try to find some other place to do this sessions. So bear with
So,
me for that.
Ananya, better to switch off your camera so that you can concentrate more. Like, so your data will be
Yes,
more
ma'am.
used on the presentation.
Okay, actually I'm using Wi-Fi now. So okay, I will switch off the camera and let's see if my voice can come correctly. Okay. So let me discuss all the questions once, and after that, if you have like problem, you didn't understand or anything, you can tell. I will repeat them. So we solved this question. Now next is the constituents in a composite combine space scale, whereas those in an alloy combine in a dash scale. So I already discussed this topic before, that this composites and alloy. As alloy also we have studied that it contains two or more different types of metals combined and formed, but they are not called as composite, because composites, when the different constituents of a composite are combined, we can see the different parts of that composite. That's why we say that these are combined at a macroscopic scale. Not even, not they may not be always be like can be seen by our naked eye, but still mostly the composite that we see around, we can separate the different parts of the composite and see, okay, this is the reinforcement, these are glass fiber, and they are combined by this matrix like epoxy or anything. We can't say which, like mostly reinforcements we can see and tell which type of reinforcement is used, not the matrix part, but still we can differentiate, and that's why we say that they are combined at a macroscopic level. But in alloy, when we see a like an alloy metal ring or anything, we can't say, okay, this part is this metal or that. That's why we say that that is combined at a microscopic level. And somebody all talked about fillers and additives. So mostly when we add fillers and additives, we don't consider that as a reinforcement in our composite. That comes as they are not binding the they are actually modifying the properties of either the matrix or the reinforcement. So we are not considering the properties of that filler or additive separately, which will add on to the properties of the whole composite. So that's why that we don't consider as one separate constituents, and not as a reinforcement. So here also the answer will be option B. The composite is at macroscopic level, whereas at microscopic level is alloy. Did the screen stop sharing?
No, ma'am.
Was I audible last time when I discussed that question?
Yes.
No, ma'am. I think there was a lot of interruption.
Let me try to change my mic.
Am I audible
Know
now?
how big it is in meters. So I'll open up a trusty calculator.
Hello? Am I audible?
Okay, so the next question, question number 7 is that Young's modulus and density of graphite fiber are 230 gigapascal and
मैम क्वेश्चन
1000.
नंबर 6 नहीं हुआ.
हुआ था, ऑडिबल नहीं था शायद. हेलो, ये वाला क्वेश्चन हुआ था क्या? ये अनुज?
ये तो लास्ट क्वेश्चन वाज क्वेश्चन नंबर 5.
Okay, then I will discuss this one. So question number 6 is that the constituents in a composite combine in slash scale, whereas those in an alloy combine in a slash scale. So we already discussed that there are two types of materials, composite and alloy. So whenever we talk about alloy, we also think about, okay, the alloys also have different metals combined with each other, so that can also be act as a composite. But alloys are not composite because in composite we can see all the constituents with our naked eye, or even if not with the naked eye, but we can differentiate it whenever we see a composite that okay, these parts are the reinforcement and the others are matrix. So that's why we say that the composites are combined at a macroscopic level. Whereas in an alloy, like the metal we got, if we got an alloy ring, so we can't see and tell that okay, which all metals are present in that, and they can already be differentiated at the microscopic level, different atoms, different metals what are used. That's why we say that alloys are combined at a microscopic level. Whereas as one of you said as a doubt if additives or fillers can also act as composite, but no, because additives and fillers when they combine, they mostly combine with one of the either matrix or reinforcement to enhance their property. So individually these fillers and additives, their properties are not uh, contributing to the composite, rather they are enhancing one of the properties, parts of the composite. That's why we don't say when we add some additive that also they are the reinforcement, and but they can be part of the composite, but they don't act as any of the phases like matrix or reinforcement. So that's why for this question the answer will be that constituents of composite are macroscopic, whereas for the alloy it is microscopic. So the next question is question number 7. So the Young's modulus and density of graphite fiber are 230 gigapascal and 1800 kg per meter cube respectively. Young's modulus and density of steel are 206 gigapascal and 7800 kg per meter cube respectively. The ratio of the specific modulus of graphite fiber to that of steel is. Okay. So when we have like sir also taught in his lectures that mostly we compare the properties of a composite that of a metal, and when we compare the composite came in picture because this mechanical properties are comparable to that of metal. For this like metal and composite can give the same amount of strength and it can withstand same amount of force almost. And but the most uh, useful like advantage of this composite comes from the weight, as the weight of composite is very much lesser than that of the steel. That's why in future also, like I work on composite and I mostly work on like cylinders. So there are different types of cylinders, like the one that are already we use in our house, they are like the LPG cylinders, so those are metals, so they can store that gas, but it is very heavy. And these kind of cylinders are also used in like automobiles also, like new cars are coming which are CNG cylinders inside it. So because of their weight also, they are decreasing the efficiency of the car. In replacement of that metal cylinders comes the composite cylinders. So these composite cylinders, they have the same amount. We can build the same cylinder in composite with the same amount of mechanical strength, but it mass will be less. As the mass will be less, it will increase the efficiency of the car. So that's why this is like an example of how people are moving towards composite from the usual metal that we already use, because the best benefit we get from the composite is because of weight. Now in this question, it is to compare the specific modulus of a graphite fiber to that of a steel. This will show how these graphite fibers uh, giving the specific modulus higher than that of steel. The specific modulus definition, the formula for specific modulus is the Young's modulus divided by the mass density. So the Young's modulus of a steel and a graphite fiber will be comparable, but the mass density of a graphite fiber will be very less. So because of that, the specific modulus will be higher of a graphite fiber. So in this question, as the equations So in this question, the equation is given of specific modulus that is equal to Young's modulus by mass density. So the Young's modulus and mass density of the graphite fiber is given to us. The Young's modulus 230 gigapascal and the mass density 1800 kg per meter cube. And for the steel is also given to us. And we have to find the ratio of the specific modulus of graphite fiber to that of steel. So when we will find the ratio of specific modulus of graphite to the steel, we can put this values here and we will get the value between 4.8 to 5 as the ratio. Next question is the same kind of question. So here they are talking about the ultimate tensile strength. So question number 8, they are saying ultimate tensile strength and density of UD graphite epoxy are 1500 megapascal and 1600 kg per meter cube. UD graphite per slash epoxy is a composite where the graphite fibers are unidirectional. So UD means unidirectional. So the graphite fibers are aligned at unidirection and the matrix is the epoxy.
Fine, yeah.
I'm so sorry. Again, my internet left went. So, uh, do you guys have any doubts in the assignment one?
Yes, ma'am. We not understanding the.
No, the problem is, yeah, it's not audible properly, and there is lot of interruptions in between.
Okay.
Okay.
Uh, I was thinking that
Question number
I
seven is question number seven is not understand, ma'am.
question number 7.
Yes, the modulus nth modulus of the density.
Uh,
Okay. So I will try as much as I can explain here. I will re-record this whole like my PPT, and I will be putting that in YouTube also. So if you have doubts after in the you can also ask in the comments of that YouTube video also. You will get it. NPTEL will provide you the YouTube channel. But let's like I am trying my best to get to explain all the questions to you. I'm very sorry my internet is not working properly in my hostel here, but as much as I can explain, I'm trying. But still, if you have doubts, these sessions, and I will record this whole PPT session properly and put it in YouTube. Again, gone.
Hello, ma'am.
Hi, yes.
Uh, the better to share the video, ma'am. The YouTube. We will there.
yeah,
Huh,
ma'am.
that, when I will
Uh,
upload it in YouTube, NPTEL will send you the link of my YouTube channel and you can go and see all the video solutions there also.
yeah, ma'am.
Okay,
Actually,
ma'am. Okay.
um,
Because no, a lot of problem
on
is there.
some other day also,
Voices is not clear.
because if this kind of interruptions are going on like this, means then it won't be much productive, right?
Yes, yes. Uh, Live sessions are mostly that if you have doubt, then I can clear and also to discuss this. But next time I will try to find some other place with good internet. But mostly in like I am
And
in IT Kharagpur. It doesn't happen all the time, but I don't know why today it's showing so much disturbance.
also, ma'am, like instead of having in this one, is it possible to have in MS Teams? But MS Teams is very nice app.
I have to talk to the NPTEL like department if MS Teams will be okay or not. Then I have to share another
Okay.
new link. That's why I will ask.
Attended like this only. Yeah, it's through the MS Teams only.
Okay.
That will be much effective rather than this one.
Okay, okay, I will see. Actually, last year also I have done like this, but this time it is showing like I'm having so much problem only this session because my internet is going and coming back like so many times. Okay, let's continue. Okay, so question number 7. Young's modulus and density of graphite fiber are 230 gigapascal and 1800 kg per meter cube respectively. Whereas Young's modulus and density of steel are 206 gigapascal and 7800 kg per meter cube respectively. The ratio of specific modulus of graphite fiber to that of steel is. Now, these questions come from the concept that why composite is useful. So initially, like traditionally, we are using metals for all the things like cylinder and parts of the car and everything. But now in future, we are moving toward composite. The main reason behind it that the mechanical properties of a metal is almost comparable to that of composite. And the benefit of using composite is that the mass of the composite is less compared to metal. That's why in longer term, with a reduced mass of our final product can also be a very beneficial. It can also be very beneficial. That's where the concept of this question comes from. So here they are trying to find the ratio of specific modulus of a composite reinforcement to that of steel. Now the formula specific modulus is Young's modulus divided by the mass density. So the Young's modulus and mass density of graphite fiber and steel is given to us. So we have to find the ratio that of specific modulus of graphite to the steel. So this is the specific modulus of graphite and this is the specific modulus of steel. So when we divide, we will find the ratio that will come, the value will come between 4.8 to 5. Okay, so from this you can see how much the specific modulus of the reinforcement is better than that of the metals. So the next question is the same, but here we are using the ultimate tensile strength. So option A, question number 8 says that ultimate tensile strength and density of unidirectional graphite slash epoxy are 1500 megapascal and 1600 kg per meter cube. Ultimate tensile strength and density of steel are 648 megapascal and 7800 kg per meter cube. The ratio of the specific strength of graphite slash epoxy to that of steel is. So in the last question, it was asking specific modulus. Here they ask specific strength. So in here you took the ratio of the Young's modulus. In this question, you have to do the ratio of the ultimate strength by the mass density. So the values of the ultimate strength and mass density of the unidirectional graphite epoxy and the steel is already given in the question. We just have to find the ratio. It will come around 11 to 12. So those questions were audible, right? Any doubts on that?
No, ma'am.
Okay. Now I think I have to like check all the time, come back and see if my screen was even sharing or not, if my mic was working or not. I'm so sorry. Next time I will try to find some other alternative to have a better internet. This doesn't work like this, like here mostly. I don't know why it's happening. Okay. Next question. Question number 9. So question number 9 is glass fibers have dash chemical resistance and dash conductivity compared to carbon fiber. Now, before this question, we were talking about composite. Now we came to one part of the composite, that is the reinforcement. So as initially I said, there are different types of reinforcement. Most common are glass fiber, carbon fiber and aramid fiber. So they are used according to what mechanical properties we want to enhance in our composite. So glass fibers have higher chemical resistance and lower conductivity compared to carbon fiber. So these are, there is no like no hard fast logic I can explain, but this is a known factor to us that glass fiber will have a higher chemical resistance but will have lower conductivity compared to carbon fibers. Whereas in question number 10, the glass fibers have dash specific modulus and dash specific strength compared to carbon fiber. So glass fibers have lower specific modulus and lower specific strength compared to carbon fibers. Now we have to keep in mind these properties when we are trying to design our composite. Like uh, pipelines and cylinders. I mostly work with pipelines and cylinders. So when we want very high pressure storage, that time we go for carbon fibers because carbon fibers have very high modulus and strength. But in conditions where the pressure required for storing some gas is very low, at that time we can go for glass fiber because comparatively glass fiber is very much cheaper. And also for any pipelines we are making which contains some chemicals and all, at that time also we go for glass. So according to our application, we have to choose wisely which kind of reinforcement we have to use. So our first choice have to be the reinforcement. But reinforcement because reinforcement is the load bearing constituent. So we will choose our reinforcement. Then comes the matrix that combines with that reinforcement. So there is always different grades of reinforcement and matrix, and they are not all like you can't mix one type of polymer with any type of reinforcement. You have to go study the TDS and see which kind of reinforcement is compatible with which specific type of matrix and all, because there is if they are not compatible, then the strength of the total composite will not be that good. So that things we have to study when we are choosing which type of resistance and matrix we have to use. The next question is a lamina is dash and dash. So now we came to the concept of lamina. So the definition of lamina is that it contains one layer of reinforcement and matrix. So first we had a separate matrix, a separate reinforcement. Now we combine them and that forms a lamina. So a lamina will have the properties of both the reinforcement, the fibers and the mats and everything that we're using as reinforcement, and the matrix, which is actually a polymer like epoxy, polyester, and all those. So that forms a lamina. And when we stack more than one laminas, it forms a laminate. So that is another term that sir already taught in his class. So a lamina is heterogeneous and anisotropic. What is heterogeneous mean? That the properties are location dependent, because a lamina contains both reinforcement and matrix. So when they are combined, then at some point in that composite there will be more amount of reinforcement. At some point it will be only the matrix part. So it is not uniform. That's why we say that it is heterogeneous. Whereas anisotropic means the properties are direction dependent. A matrix is isotropic. That is, in every direction, the properties will remain same. Whereas the fiber, suppose you take a fiber, a thread. So its tensile strength will be higher and the longitudinal modulus will be higher, transverse modulus will be lower. So that means in every direction, the properties will be different for the reinforcement. Now, because the matrix is isotropic and the reinforcement is not isotropic, it is so that's why when we combine these two, it becomes an anisotropic. That is, in every direction, the properties will remain different. That's why lamina we say it is heterogeneous and anisotropic. So where did the connection loss? Like what was I explaining last?
The carbon, the glass fiber and lower uh,
Question
conductivity
number
like
10.
that. 10th and
Yes, ma'am.
ninth.
Ninth and 10th, right? Ninth and like
Yeah.
I finished the ninth and 10th because I explained
Yes, yes, the
question number
both also you
11 and
done.
Yes,
okay.
ma'am.
Both
So question 11
both
I will
also
explain.
completed. Okay.
Okay, so question number 11 is that a lamina is dash and dash. So a lamina contains first we studied about the reinforcement and the matrix. Now the lamina is one which combines the reinforcement and matrix and forms the whole composite. And when more than one laminas are there, it forms a laminate. So these terms are already explained in the class. So now a lamina contains the properties of both the matrix and the reinforcement. So that's why we have to find the option which is correct. So the option which is correct will be option A, heterogeneous and anisotropic. Now what does heterogeneous mean? It means that the properties are location dependent. Now a lamina will have both reinforcement and matrix. So at one point at any point it can have more matrix and at one point it can have the reinforcement. So it is not uniform. That's why we say that a lamina is heterogeneous. Whereas anisotropic is the properties are direction dependent. Now in the lamina, the matrix is isotropic. That is, it is a continuous phase and the properties are same in all the directions. But the reinforcement that we use, that is not isotropic. Its transverse modulus and longitudinal modulus will be different. That means in different all the three directions, three axes, its value will be different. The strength of the reinforcement. So when we combine the reinforcement with the matrix, the whole composite, the lamina, will become anisotropic. That is, at all the directions, the properties will be different. That's because of that basically because of the reinforcement, because the properties of reinforcement are different in different directions. So when it's combined with the matrix and form the composite, then the whole composite will have different properties at different directions. That's why lamina is heterogeneous and anisotropic. Okay, so now doubts. Any doubts? Which questions should I repeat?
No, ma'am.
Actually, this
Ma'am,
assignment one was very easier one. Most of these questions which were asked in the assignment, sir have said
hello.
all the answers in the video. Huh? Vinoda?
Hello, ma'am.
Yes.
Yes, ma'am. I am Vinodha here.
Yes, Vinoda. Am I audible?
Hello.
क्यों हो रहा है ऐसा? मेरा सर दर्द हो रहा है. Hello, Vinoda? Vinoda?
Yes, ma'am. Yes, ma'am.
Yes, you're saying something.
Could you, that one you said, ma'am, that one heterogeneous. Could you explain the in short heterogeneous?
Heterogeneous means that throughout the composite, the properties will be different. Like, look, the properties are location dependent. That's why we say it heterogeneous because the whole you have a whole composite plate. So there, at some point, you can
Yes.
see there will be reinforcement. At some gaps, there will be only matrix and no reinforcement. That's why we are saying that at all the locations, the properties will not be remaining same. That's why it is heterogeneous and not an
Okay.
homogeneous. Okay.
Okay. Thank you. Thank you.
In the chat, I am trying to put my YouTube link. So by tonight, I will re-record this whole session and I will put it there. Okay, so you guys can see that, and if you have doubts, you can put it in the comment. So wait a minute. Any other doubts?
Okay, you go ahead, ma'am. Next one.
Assignment 2, the submission of assignment 2 is 6th. I think, wait a minute. 7th February, right? So 6th February, there will be another session. So at, till 6th, you complete your assignment 2. And after that, if you have doubts, you can ask me on the 6th February session. Okay. Marking everything. Hello. So, assignment 2, I will be discussing on next class. Okay. Because the submission of your assignment is 7th February, so I thought 6th February I have a session. So by 6th February you complete your assignment too, and after that if you have some doubts, then we can discuss on 6th February. Did you guys get that link of the YouTube channel? No, right? Hello. So you can get from this YouTube link. I will by tonight. I will put the video of like the solution of this whole assignment. You can see that. Okay. Sorry for all the problems, disruption in this live session. Next live session, I will try to do it from a better place so that we don't have these problems. Okay. Sorry.
Okay, ma'am. Thanks.
Okay, ma'am. Okay, ma'am. No problem.
Okay, so we will
Good
end the
night.
session here. So next session,
Yes.
finish your like working with assignment number 2, and any doubts in the assignments or anything that sir taught, you can ask me in the next class. Okay, next Tuesday.
Okay, ma'am.
Okay, thank you
Okay,
so
ma'am.
much to bear
Okay,
with me.
good
I'm
night,
so
ma'am.
sorry.
No problem, ma'am.
Okay, thank you.
Okay, ma'am. Thank you. Good night.
Good night.
Okay, ma'am.
Okay,
Thank
thank
you.
you. Thank you.